Okay, welcome to the We Are Ready Day 14 Solution Manual video. This is the 14th of 16 videos designed to help you prepare for the ISTEP10 Math retest. Here we have if t cubed equals 64 over 27, what is the value of t? Well, if t cubed is equal to 64 over 27, then in order to get t, we need to get rid of that third exponent, which means that we need to take the cube root. Now, when you take the cube root of a fraction, you're really taking the cube root of the top number and the cube root of the bottom number. Both 64 and 27 are perfect cubes. The cube root of 64 is 4. The cube root of 27 is 3. So your answer should be 4 over 3, or 4/3. This one's kind of a real important one. Here, notice that none of these graphs are labeled, but we're supposed to tell them which graph best represents the solutions to this particular system of inequalities. X plus y is greater than 3, and 2x minus y is greater than or equal to 1. Now, let's keep in mind what we're looking at here. All four of these pictures have the same two lines on them. The only thing that's different is whether those lines are solid or dotted, and whether we're shading above or below the lines. And we can tell all of that right now. Okay? X plus y is greater than or equal to 3. That line, okay, this line is that line. That is the one that we're looking at there. So we just have to determine, is that supposed to be solid or dotted? Well, look at the line, or the sign. Greater than means it should be a dotted line. So right away, the only answers that should survive your initial answer eliminator tool, A cannot be the answer and B cannot be the answer, because in both cases, they're showing that line as a solid line. Now, the other thing that greater than tells us is if y is greater than something, that means we are shading above. Well, that doesn't help us narrow it down any, because both of these potential answers have areas shaded above that line. So we have to move to the other line. So this line should be a solid line. Of our two remaining answers, they are both solid lines, so that doesn't help us. And since y is greater than, actually, let me think about that there. Let's solve that for y. So let's move that 2x to the other side by subtracting 2x from each side. That would give us negative y is greater than or equal to negative 2x plus 1. And then we're going to divide everything by negative 1. Now, when we do that with an inequality, we have to reverse that symbol. So this becomes y is less than or equal to 2x minus 1. Now notice less than or equal to, that means we're going to shade below. So, if we look at our two options, and remember we're looking at this line. This is the line that we're dealing with right now. We have to ask ourselves which one of those shows shading below that line. That would be answer D. Next up, number 3. Ian tosses a bone up in the air for his dog Spot. The height in feet that Spot is above the ground at the time t seconds after she jumps for the bone can be represented by the function h of t equals negative 16t squared plus 20t. What is Spot's average rate of ascent? Those are the key words right there that tell us what we're supposed to be doing. In feet per second from the time she jumps into the air, which would be 0, and her height is 0 when she jumps, to the time that she catches the bone at t equals 1/2. Well, that means we need to know how high that dog is at 1/2. So we need to know the value of h of 1/2. So that's the first thing we do, is we figure out that value by plugging 1/2 into the function. That would give us negative 16 times 1/4 plus 10, or negative 4 plus 10, meaning h of 1/2 is 6. So that means that we're looking at the point negative 1/2, 6. Now, average rate of ascent, that's like saying average rate of change, which means we're no longer dealing with a quadratic equation. It's not what it's asking. It's asking for an average rate of change. It's asking for a slope between these 2 points. So we have here x1, y1, x2, y2, and we're going to plug into the slope formula, y2 minus y1 over x2 minus x1. Now that's actually relatively easy to do. That's 6 minus 0 divided by 1/2 minus 0, or 6 divided by 1/2. So that would be 12 feet per second. And we would answer a 12 in that box. It's a very challenging question. Number 4 says, what is the domain and range of h of x as shown in the graph? Remember that domain is your x values, your input, and your range is your y values, your output. So the way that we do domain is we move from left to right on the graph and we say, is there anywhere where this does not exist from left to right? The answer to that question is no. This graph exists everywhere for every x value. There's no x value we're not allowed to plug in. It shows it going up, but it doesn't show it definitely running into a vertical asymptote, which probably means you really probably are not going to see a question like this on the ISTEP. But this idea of domain and range is very important because you will see domain and range. So if we move from left to right, every x value exists, which indicates that the domain is all real numbers. That would eliminate C, and only C, because all the other ones have that domain of all real numbers. Now in terms of the range, you'll notice that h of x never actually goes below the line y equals 2. So if when we're looking at range, we go bottom to top and we say, where does the graph exist? Where does the graph not exist? Well, this graph does not exist anywhere below the line y equals 2. It doesn't cross that line. So this would be a range where y is greater than 2. Meaning that A is not correct, B is not correct. The correct answer to this particular question is D. Number 5 and number 6 are asking you to identify growth and decay. I would hope that this would be extremely easy. What you're looking at is how y changes as x changes. So as we move from left to right, as x increases, y increases. That indicates exponential growth. And on number 6, as x increases, y decreases. That indicates exponential decay. That does it for the day 14 video.